Okay, this is the last section in Chapter 3, and what we're going to do here is we're going to take a look at some advanced factoring techniques. This may or may not be included in our curriculum, but we want to be able to do these because they're just good formulas to know. So the I can statement is I can factor difference and sum of, not squares in this case, but this is going to be cubes. So we're going to be factoring difference and sum of cubes, and we're going to learn some advanced factoring techniques. So I'm hoping you've had a chance to take a look at the warm-up for just a second and figure out what's going on there. This first one says factor that trinomial. So we've got an x squared plus an x plus a 1. And this is an easy trinomial because it starts off with a 1x squared. So we can just go ahead and start writing down some sets of parentheses. And we know the only way to make our x squared is going to be an x and an x. And then we need some numbers that multiply to be 1 that combine to be 1. So if we stop and think about that, our choices are 1 and 1 and -1 and -1. And both of those we either make a 2 or a -2. No way to get around it. So this will not work. We end up with a prime polynomial right there. Okay? And then if we take a look at the next one, it says list the cubes of the following. So not squares, cubes. So this is going to be, I'll give you a second head start. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 24, 4 cubed is 64, 5 cubed is 125. See why I put that extra space in there because we're going to need it. Let's see, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, and then 9 cubed, I'm going to skip that one for the time being, and I'm going to write 10 cubed is 1,000. If you need to grab your calculator really quickly for some of these, that's totally okay. You may have had a teacher that said, hey, memorize up through 5 cubed or something like that. I'm just going to really quickly check what 9 cubed is. I think it's 729 because I've got most of these memorized. It's 729. Now, the reason we want to have these kind of laid out here at the beginning is we're going to see a lot of numbers like this. And if you've got the perfect cubes memorized up to maybe 10 cubed or something like that, you're going to recognize them more frequently, just like you recognize perfect squares a lot. So let's keep that in mind. So if we know the basics of how to factor polynomials, there are lots of polynomials that you'll be able to factor. You can get around without knowing some of the formulae. That's the technical name for, or the technical way we spell a plural of formulas. So even things like difference of squares and perfect square trinomials, you don't have to have those memorized. You could always do it the longer way, either by factoring like they're a trinomial, either in a hard one or an easy one. Difference of squares, you could change that into a trinomial where the middle, the linear term is 0 for a coefficient. But there's sometimes where there's just no getting around the fact that you're going to have to memorize, or the formulas are going to need to be memorized. So let's write memorized right here. If you try and think or guess your way to the answer on some of the ones that we're going to see now, they're going to be very, very hard, if not impossible. Okay, so memorizing the formulas, those are just the quickest way to get the correct answer. And it's going to save you a lot of time. So we're going to talk about difference of cubes first. So when we've got a difference of cubes, it's similar to the way we factor difference of squares. We're looking for the same types of things, but the answer is going to turn out to be very different. So if it's a difference of cubes, again, this is just a binomials. There's only 2 of them, and here's what we're looking for. Is the first term a perfect cube? Well, this is a cubed, so obviously that's a perfect cube of A. And is the second term a perfect cube? This is b cubed, so perfect cube of b. And are the terms subtracted? In other words, is it a difference? Okay, that's why we call it a difference of cubes. If that's the case, then we're just going to write down the factors. The factors are the first one minus the second one, so a minus b. And then it's going to be the first one squared. And then I like saying the last one squared. And then this middle term in here is just the 2 of those multiplied together. So first one minus the second one, first one squared, last one squared, and then the middle one is just a times b, first one times the second one. And there's just a 1 in front there. You'll notice that the coefficient of every single one of these is just a 1, at least for right now, because we've just got a 1 in front of those. So that's the way I memorize those. If you like formulas, here's a formula. You can kind of take a mental picture of that. Or you can say first one minus the second one, first one squared, plus the first one times the second one, and then plus the second one squared. Okay, and you can think of it however you need to get these memorized. So let's take a look at this one right here. Here's our first one. So the first thing is the first one a perfect cube? If so, of what? So this is x cubed, so that's a perfect cube of x. Is the second one a perfect cube? Yeah, it is. Perfect cube of 2. And is it a difference? It is. So when we write down the factors, it's going to be the first one, which is x, minus the second one, which is 2. And then it's going to be the first one squared, so I'm going to write down x squared. Then just the two of them multiplied together, so this is 2 times x. And then the last one is the second one squared, so this is going to be 4. Now you might look at this and think, hey, that's a trinomial, can I factor that? But just like we were looking at up above, where we've got a 1 here and a 1 here, just like we've got a 1 right there and a 1 right there, that's not going to factor. So you can search all day long. You're not going to find numbers that multiply to be 4 that combine to be 2. You can check those out. You're welcome to. So let's take a look at this one right here. Again, first one is a perfect cube of 3b. Second one is a perfect cube of z. And it is a difference. So we're going to write 3b minus z. And then it's going to be the first one squared, so that's going to be 9b squared. The two of them multiplied together, so this is going to be plus 3bz. And then it's going to be plus the last one squared, so this is going to be z squared. And we're finished. Done. That's all we need on these. Those are the answers. And we'll take a look at this last one. I'll give you a little bit of a head start if you'd like one. So if you want to pause the video for just a second. And we'll go ahead and take a look at this. So perfect cube of 4x, perfect cube of 5y, and it's a difference. So this is going to be, 4x minus 5y. And then it's going to be the two, let's see, first one squared, so that's going to be 16x squared. The two of them multiplied together, so that's going to be 20xy. And then the last one squared, so this is going to be 25y squared. Close that off, box that in. And there is our answer, okay? Now, if we've got difference of cubes figured out, then sum of cubes is an absolute piece of cake because it's basically the same thing. Does it start with a perfect cube? Does it end with a perfect cube? And are the terms added together? So remember, there's no sum of squares, but there is a sum of cubes. So let's take a look at how this works out. So if it's perfect cube of A, perfect cube of B, added together. This first factor is going to be a plus b, so we're going to add those together in the first one. And then the second one is going to be a squared, so the first one squared, minus the two of them multiplied together, and then plus b squared there, so plus the second one. So you'll notice that there's a negative in the middle of the second one rather than the middle of the first one. So let's go through and do this then. So here's our first one. Is the first one a perfect cube? Yep. Of x. Is the second one a perfect cube? Yep. Of 3. Is it a sum? It is. So it's going to follow this pattern right here. So the pattern is it's going to be the first one plus the second one, first one squared, minus, so there's the difference. Okay, there's that in that formula right there. So, and we'll take a look in just a second about why it works that way. So then the two of them multiplied together, and we normally write the 3 in front because it's a coefficient, and then plus the second one squared. So there's our answer on that one. Let's take a look at these guys right here. This one looks a little bit more complicated. It's not too bad. Is the first one a perfect cube? It is of 2 and x and y. Is that a perfect cube? One's a perfect square, cube, fourth power, everything. Okay, and it's a sum, so we're going to write down 2xy plus 1. So again, we add the two of them together on this one, and then we square the first one. So this is going to be 4 squared. Sorry, 4. 2 squared is 4. X squared, y squared. Then we have a minus. Each one of these formulas has to have a minus somewhere. You'll see why in a second. We multiply the two of them together, so 2xy, and then plus the last one squared, that second one squared. Okay, so we've got that taken care of right there. And then we've got two terms. So this is a perfect cube of 4x. That's a perfect cube of, we listed this earlier up above, so that's going to be 7y. And it's a plus, so that makes this one a 4x plus 7y. Okay, so that plus comes right down here. And then this is going to be 16x squared minus, multiply the two of them together, so that's going to be 28xy. And then we square that second one, so that's going to be 49y squared. All right, so there we go. Whoops, got that one. Okay, let's take a look at the other side. Okay, we're on this back side, and you'll notice that I've got all three formulas that we've been talking about in this unit as far as just binomials. So if there's two terms, it's either got to be a difference of squares, a difference of cubes, or a sum of cubes. And sometimes keeping straight which is which is really difficult, but we might be able to spot some patterns. So here's what I'd like you to take a look at. Each formula has only one negative in it. And in just a second, we're going to take a look at why. So this one here, this is a difference of squares. We've got a negative in the middle of the first one. And this is a difference of cubes, negative in the middle of the first one. And then this is a sum of cubes, and you'll notice that there's a negative in the middle of the second one. So one here, and one there, only one negative. And like I was just saying, the negative is always in the middle of the factor. And in order to figure out where it goes, the first factor always has the same operation as the original binomial. So if we've got a minus in between the two terms on this one, we put a minus in the middle of the first factor. If we've got a plus in the middle of the first one, then we put a plus in the original one. We put a plus in the middle of this one, and then the negative goes in the middle of the second one. So we'll just quickly run through and take a look at each one of these. So this is going to be m cubed plus 125. So perfect cube of m, perfect cube of 5. You can do it without writing those down, but I like writing them down so I know what I'm looking at. I don't have to kind of think through anything. So again, this is a plus, so I'm going to write m plus 5. And then I'm going to write, let's see, first one squared, because that's the pattern here. So that's going to be m squared. And then this is going to be minus, because remember, we didn't put a minus here, so there's got to be a minus in the middle of the second one. So this is going to be a 5m. And then it's going to be plus the second one squared. So that's going to be 25. And we're done. That is the answer. Now, I told you we'd kind of take a look at why it works this way. So I'm going to come up here, and we're going to write down m plus 5. And we're going to write down m squared minus 5m and then plus 25. And let's actually take a look at this if we do this backwards. So we think we've got the right factors. Watch what happens when we multiply here. So I'm going to multiply the m through. So the cool thing about factoring problems is you can check and see whether or not you got the answer right by multiplying these together. So I'll do the m times the 5m, so this is going to be a 5m squared, and m times the 25, so that's going to be plus 25m. Then it's going to be the 5's turn, and so we got the 3 terms multiplying the first one through. Here come the other 3 terms, so this is going to be plus 5m squared. This is going to be minus 25m, and then 5 times 25 is plus 125. So take a look at this. There's our m cubed. So done with that one. And I've got a negative 5m squared, and we look through here, and look, these are exact opposites, so they cancel out. Then I've got a 25m, there's a minus 25m, so those cancel out. So the only other thing left is the plus 125. So that negative is really important where it goes so that we can have things cancel off the way they need to. So let's take a look at a couple more and finish this up. This is a perfect cube of y, perfect cube of z. It's a minus, so I'm going to write a minus in the middle of the first one. And then I'm going to write the first one squared. I'm going to put the 2 of them together and multiply them, so that's going to be yz, and then it's going to be add the z squared. And then you'll notice that these last ones always end up being positive. Again, the minus goes in the middle of the first one. Everything else is positive. We only need one negative in each one of the formulas. So let's take a look at this. This is not a perfect cube. This is a perfect square. So this is going to be a perfect square of 10c. Perfect square of 1. So again, according to the pattern, we take the 2 of them and we use the same sign. So this is going to be 10c minus 1. And then the other one is just going to have pluses in it. So this is a 10c plus 1. And whoops, let me make that look right. And there's the answer on that one. So difference of squares, sum of cubes, get that right, sum of cubes, difference of cubes, difference of squares. So we kind of did those in the opposite order of what we had up there. So I'm going to come down here and take a look at the end of this. These are the last couple problems that we're going to do, but I've got complete in air quotes right here. This is going to cover almost everything that you're ever going to see. So this one says the first rule is always take out the GCF. That's always going to make things easier. Keep track of the fact we want to take out the leading sign. If there are 2 terms, now we've got 3 formulas for this. It's either going to be a difference of squares, difference of cubes, or sum of cubes. And if there's 3 terms, It might be a perfect square trinomial. If you know those formulas, it makes it a lot easier, makes it much, much quicker to get the answer. And then there's the easy type of trinomial. We use that guess and check riddle method. And if it's the hard type, we multiply the a and c together and use the riddle method with that number and whatever the number in the middle is. If it's 4 or more terms, then we group them together to find a GCF within the groups, or we can group them together to make it fit a pattern like this up above. And that's some of the advanced factoring techniques that we'll take a look at in the second part of this video. And then the last thing, of course, is always make sure that you factored completely and include all the factors in the answer. So let's take a look at this one right here. You'll notice that this is a 27 plus a 512t cubed. Now, we normally write this with the variable first. We write it in descending order. If you wanted to, you could factor it this way. There's nothing special about having the t cubed or the variable at the beginning, but it does kind of fit what we normally use. So I'm going to go ahead and switch these around. I'm going to write this as a 512t cubed plus 27. Now, if this was a difference, I might have to be a little bit careful with that. We've maybe seen before where we have it where we need to factor out a leading sign of a negative. So if these were both negative or something like that, I'd want to take out the negative to make it look right. It just makes things a little bit easier for us down the road. So I'm going to go ahead and write it like this. This is a perfect cube of 8t. This is a perfect cube of 3. So this is going to be 8t, and it's a sum, so I'm going to put that sign, that operation in the middle of the first one, so 8t plus 3. And then it's going to be the first one squared, 64t squared. Multiply the two of them together. And remember, if you didn't have a negative in the first one, you got to have a negative in the middle of the second one. So this is going to be 24t, and then we end with a perfect square of that last one. So this is the answer on that. And then let's take a look at the next one. This has got a little hint here. It's always tough when we deal with fractions. So this looks like a really big mess. We might have an opportunity to factor this using a sum of cubes. But let's take a look here. And again, when I've got this hint of think GCFs, when you've got a fraction, sometimes the best way to do it is think of, can I get a common denominator, which I already have, and can I take something out of the top and can I take something out of the bottom? So on this one, if I take out a 3 out of the bottom, probably everybody can see that. So I'm going to take a 3 out of the bottom, and then out of the top I'm going to take a 2. So what I really want to do is I want to take the 2/3 out. I want to make this look like just a y cubed. Well, that's easy on this one, so this is just going to be y cubed. If I take a 2 out of the top, a 2 out of a 128 is a 64. And a 3 out of a 3 is a 1. So I don't need to put the 1 on the bottom. I can just write the 64. Now we've got this looking a lot better in one step by taking out that factor. Looks a lot better. So this is a perfect cube of y and a perfect cube of 4. So I'm going to go ahead and take the time to write the factor out front now. And then this is going to be y plus 4. So first one plus the second one. First one squared minus the two of them multiplied together, and then plus the last one squared. And that quick, we've got the answer. Now on this last one, this one might be a little bit tricky here. We haven't dealt with decimals very often, and you might like decimals. I'm not a huge fan because I always have to get my calculator out for every single problem that I do. But let's take a quick look here. Could we make this look as something that's more familiar? So that is definitely a perfect cube of z, but this right here, this is 10th, 100th, this is 1,000th. So we could do this in decimal format, but I think it'll be easier if we think of this as a fraction. This is minus 1/1000th. Okay, so whether you think of it as a decimal or think of it as a fraction, this is going to be 1/10 cubed, or it's going to be 1/10 cubed. And I think this is easier to see right there. But it did do it in decimal form to begin with, so let's go ahead and do this as decimals. So this is going to be a perfect cube of z minus a perfect cube of 1/10. And if you want to check that on your calculator, you're welcome to. So this is going to be z minus 0.1, and then the first one squared, so this is going to be z squared, plus the two of them multiplied together, so this is going to be 0.1z, and then plus that one squared, 1/10 squared is going to be 100th, so this is plus 0.01, and there we go. And again, if you wanted to do the whole thing in fraction form, you would be welcome to do that also. All right, good luck on the assignment. These are good ones to practice.